Hello everyone, I'm Sunil. I welcome you back to my YouTube channel TechBasics. So in the previous video, we have seen how to make use of a for loop, and then we have written some simple programs based on for loop. And there we discussed, so whenever you want to increment a value, instead of you writing I equals to I plus 1, we can as well make use of I plus plus I. And then when you want to decrement, you can make use of I minus minus R minus minus I. There is a little amount of difference when you make use of this unary operator. So these operators like plus plus and minus minus, you can call them as unary operators. Unary operators because they are going to work on one operand. You require only one variable to work with that particular work with that particular operator and so on. It is something like I plus plus R plus plus I and so on. Whereas in case of binary operators you require like say addition, subtraction, multiplication, division. So wherein you are going to have or you are going to make use of two operands over there. So unary operator and binary operator. So let's understand in detail about these unary operators. So plus plus can be used for incrementing the value of I by 1 or a variable by 1. You can write I equals to I plus 1 as plus plus I or I plus plus. But the difference here comes whenever you assign the value to some other variable. I equal to I plus 1. I can write it as I plus plus R plus plus I. It makes no difference for me. But when you make use of A equals to 100, B equals to A plus plus, then you will find the difference between A plus plus and plus plus A. Now here, after you perform this, if you check the value of A and B, here the value of A is going to be 101 and the value of B is going to be 100. That is because when you say B equals to A plus plus, what happens here is, first it will assign the value and then it increments. So first it will assign the value, that is value of A is assigned to B so that B becomes 100. Later the value of A gets incremented so that A becomes 101 and so on. So the difference comes when you equate the value to some other variable. In the similar way, if A equals to 100, B equals to plus plus A, then what happens is, here you will get the value of A equals to 101 and you will also get the value of B equals to 101. That is because here first it will increment the value and then it assigns the value. So first incrementation will happen. So when incrementation happens, A value becomes 101, that is stored in B. So A and B will become 101. The same is the case when you work with the decrement operator. If A equals to 100 and B happens to be A minus minus, then the value of A after this operation and B will be, the value of A is going to be 99 and the value of B is going to be 100. That is because first it will assign the value, later it gets decremented. In the same way, if A equals to 100, B equals to minus minus A, then the value of A is going to be 99 and the value of B is also going to be 99. That is, first it will decrement and then it will assign the value and so on. So that is how you can work with these unary operators called plus plus and minus minus. Okay, we'll go with the programs that you want to write with the help of a for loop. So there we'll try to write a program to display the factorial of a given number. So, which means what? You want to accept a number from the user and you want to display the factorial value of that. Now, if the number given by the user is 5, then what is that you want to do? You want to calculate the factorial as 1 into 2 into, you will multiply 1 into 2 into 3 into 4 into 5. If the number happens to be say 7, then you are going to calculate the factorial as 1 into 2 into 3 into 4 into 5 into 6 into 7 and so on. That means what? If the number is given as 7, you need to multiply from 1 to 7. If it is 5, you need to multiply from 1 to 5. Or you can as well do, if the number is 5, you can multiply as 5, 4, 3, 2, 1. If it is 7, you multiply from 7 to 1 and so on. Whether you multiply from 1 to 5 or 5 to 1 makes no difference. So this is how you are going to write the program. So you can write in this fashion. You can say include IO stream. You will make use of your namespace over there. And then you are going to write your function called main. It can be integer main, void main. We'll try to understand why integer, why void when you go with the concept of functions. And then you now take NIF. So what is NIF? N is for accepting a number, I is to ensure that your loops go from 1 to that number, and F is the initial value of factorial. As you perform multiplication, you are supposed to initialize F value with 1. If it is summation, then you will initialize that value with 0. Now you can request the user to enter a number. And then you can take the number from the user. Now once you know what is the number, then you can write a for loop over there wherein it should start with 1 or 2, because 1 makes no difference when you multiply, and you need to take that number up to n. So you need to carry the value of I from 1 to n, incrementing every time by 1. And what is that you need to do? So initial value of I is 1. So what do? You say F into I. So what happens? F value is 1. I value is 1. So initially it will calculate 1 into 1. And the value will be stored back in F. Next time the value of I will be 2. So initial value of I is 1 into 2. So what is the next new value of F? That is 2. Next time the value of I will be 3. So it will now calculate with the previous value of F, which is 2 into 3. So that is 6. So F becomes 6. Next time the value of I is 4. So it becomes 6 into 4. Likewise, it continues. And then you can directly display here the factorial value. That is F. So this is how you are going to write the program. You can check the output there. Sorry, I have to comment this. So your program says enter a number. You provide some number over there. Let's say the number is given is 5. So you give 5. I'll run the program again. Give the number as say 5. Then you will get the factorial for that. You give the number as 6. You will get the factorial value of that, 720. You try to give the value as 7, 720 into 7, you can get 5040 and so on. If you give the value over there as 4, you will get the factorial for that as 24 and so on. So you can, what is that we are trying to do here? You are accepting a number, and from 1, you are going to multiply that number up to n. You can as well write it as I equals to n. You can start from last value and then you can come down up to 1. Either way you can write this program. So in both the cases your output is going to be the same. So what you have done here, if n is 5, you are starting from 5 and you will go down up to 1 multiplying the value over there. Run the program. give the number over there, you get the same output for that. So whether you multiply from 1 to 5 or 5 to 1, it is not going to make any difference for us, and so on. So I hope this particular program is clear. I'll try to write one more program over here to accept a number and display whether it is prime number or not. So what is that you want to do? You want to write here a program wherein you want to accept a number and you want to display whether that number is prime or not, whether it is a prime number or not. So we need to understand before writing this particular program, what is the prime number. So as we all know, prime number is a number which has the factors as 1, or you will have a factor as itself, 1 and itself. So prime number will have only two factors. The first one is 1 and the other one is itself. So if you take a number as 5, then 5 will be divisible by 1 as well as it is divisible by 5. And there will be no other factors for this particular number apart from 1 and itself. Only those numbers you can call them as prime numbers. So how is that we are going to write a program over here? So what you do, you accept a number and then you divide that particular number. Suppose say your number is 5. Then you divide that number by 1. You divide that number by 2. You divide that number by 3, you divide that number by 4, you divide that number by 5, and check for the remainder after every division. So you will find that the remainder is 0 over here and the remainder is 0 over here, which means what? Whenever you want to check a prime number and when you divide that number from 1 to that particular number, you should get only two factors. Otherwise, you will say it is not a prime number. So if it is divisible by 1 and itself, only then you will say it is a prime number, otherwise no. If you take an example of say 4, if n is 4, then when you divide n by 1, when you divide n by 2, you will divide n by 3, you will divide n by 4. So when you divide it by 1, you get the remainder over there as 0. When you divide by 2, it is 0. When you divide by 3, it is 0. So if you are going to get more than two factors, it means it is not a prime number. So what is that we do is, instead of we dividing for so many times, you can avoid this. Any number is divisible by 1, any number is divisible by itself. So why is that? I need to check that. I will only divide, if the number is 5, I'll only divide by 2, I'll divide by 3, I'll divide by 4. And if any point of time I get the remainder at 0, I can stop the process and say it is not a prime number. In this case also, I will not divide this number by 1, I will not divide this number by 4, because we know that anyhow a number is divisible by 1 and itself. So now when I divide by 2, if I get the number over there or the remainder over there after division at 0, I will stop the process. I will not continue further. Otherwise what happens, if the number is 100, you will divide by 2, you will divide by 3, you will divide by 4, so on you will continue up to 99. But once you get here, the remainder at 0, you can stop the process and you can say number is not divisible, number is not a prime number as it is divisible by more than two numbers. So that is the logic we'll try to implement over here. Just comment this. So what is that you do? You write hash include IO stream. You say using namespace std. Then you can say integer main. You take a number and then you take I and then you take a counter. Counter is to count how many times the number got divided by other number. That is, when you divide that number, you need to check how many times or how many factors you got for that number. So initial value of that counter is say 0. If the number is divisible for 2 times, the value of C will be 2. If the number is divisible by 3 times, then the value of C will be 3. And based on that value, we will check whether the number is prime or not. Try to understand this. Now what do you say to the user? Enter a number. So user will give some number over there. pick up that number, and then what do you say now? For I equals to, don't start with 1, don't go up to itself. So you start with 2 and you go only up to n minus 1. So you say I less than n, not equal to n, I plus plus. Okay. So there you say if n% I, if the remainder is equal to 0, you say C plus plus. So what it means now, if suppose say your number is 6 and the value of I initially will be 2, 6 by 2, it is 0. So increment C, you have incremented the value of C, means the number is not a prime number, and you don't have to continue this process. You can break over here in this fashion. So you can write, you can break like this, and later you can say if C value is going to be 0, then you display here that the number is prime number. But if the C value is not 0, then you will display in else part, you display that it is not a prime number. Yeah, you can check this now. Run the program. It says give a number, you provide a number. Suppose say your number is say 5, then it says your number is a prime number. You provide the number, suppose say it is 6, you provide the number, and if it is going to be 6, run the program. If it is 6, it says it is not a prime number. So on a basis of this value of C, you are able to find out. So let's try to display the value of C for understanding. Value of C, you try to get that value so that you will come to know. So if the number is 6, then you will get C value as 1, which means what? Apart from 1 and itself, it has one more factor. So it is not a prime number. If it is say 5, then you will get C value at 0, which means apart from 1 and itself, it has no other factors. So it is a prime number. If the number that you give is 100, it says the value of C is 1, which means it is not a prime number. So you will get here the value of C as 1 only, because anytime if the value of C is incremented, you have stopped the process by making use of a break statement. So this is how you can write a program wherein you can accept a number and then you can check whether that number is prime or not. So try to execute these kind of programs, and then in the next video we'll try to understand nested for loop, and then we'll try to understand while loop along with do while loop. So do subscribe to this channel and then try to press the bell button so that you can get the notifications in future. Thank you.